Yeah, I can hear you.
Cool. So let me share my screen. You can see my screen?
Yeah, I see you're sharing the IDE.
Good. So this week, we actually make a lot of progress from the Summer of Code team. Let me share the actual UI for the ISD Rust graphic application. So you can see this is a fairly complete features for the UI. If we compare this with the existing UI, they're very similar. With these tags, things like that. The syncing is not implemented, but like the search and those tags is working. So today we're going to look at some of the code, and actually also like the QR code. We also implemented some like editing functions. So those actually could be edited. So in the existing implementation, those cannot be edited. It's immutable after it's created. So this is the current progress in about a few weeks. So let's do some code review for what happened on the code, and the actual branch is happening for those changes. So here we see a merge request from Captain Fish, which is a developer. So he is making a new PR, a pull request. We try to merge into the master, and we can look at the commits. So he make a couple of actually like 12 commits. So every one of them is some changes, and this tab shows the actual changes, like have all the changes showing on the UI like side by side for what actually changed for those files. So we can see a lot of files changing, especially the this folder, this ISD folder. So a lot of code added into this folder for that graphics application. There are also some other changes, like those are other things we may be needed for package, like those icons. Those are the actual code for the ISD part, or for the bundle part. So the bundle part is we're trying to install this application to the person's machine. Because if you recall, we have the browser extension. So this extension is going to talking to the underlying host, right? And so on Windows we have to change the regex registry and have a manifest file. So those are some things needed to change on the user's operating system. On Mac and Linux, you also need to change some files. So those bundle is kind of the installation application, trying infrastructure and the development. So here you see something like we are converting the host, which is the files we want to copy into the person's machine, and then the browser extension can actually talk to the host executable and communicate with each other. So this is the bundle is still in progress. And then this is there are some other things about like changing the upgrades versions of the dependent libraries. So we see some of the existing function has those are like SQL functions, a query database, and the particular syntax for each of those functions have slightly changed because we upgraded the library version, and the signature of the function, which is you see they rename those signature functions by remove those named postfix. So because we upgrade the underlying libraries, so those functions also need to change, and those additional parameters also need to change. So adding those parameters. So you see a lot of those changes. And here is a particular one that is interesting. Is for the tag. So I'm not sure you're familiar with like hash set or like kind of any dictionary data structures. So there is a caveat. Like when we type in, let's see, we type in some tag 1, tag 2, tag 3, or like tag 0. If we enter this, we see those tags 1, 2, 3, 0. We also want it to be the same order. When we type in, it's 1, 2, 3, 0. It's 1, 2, 3, 0. 1, 2, 3, 0. If we also have like some duplicates, we have some duplicates. We want the duplicate. Tag 2 is duplicated. We want the tag 2 to be only stored once. We only store once, even a duplicated. And we also want that to preserve the order. Like if I'm going to say I have a tag X, I want the tag X to be the first one. I kind of follow the same order I put it there. So this is kind of the treatment, and there are some other treatment. Like if we have commas, we have space, we have commas, we have comma and space, kind of out of control with this kind of syntax. Let's throw a duplicate there. We want the comma and the space to be removed and deduped, and also preserve the order.
So if I put in tag X, tag 1, tag 2, tag 3, and there's a result that has those tags in different order, it will not show up.
Can you say it again? Tag what?
If I have 3 tags, and if I have tag 1, 2, 3, and it goes from 1 to 2 to 3, and then if I have a result that has tag 2, 3, and then 1 instead of 1, 2, and then 3, will that result not show up because it's not in the right order?
You want to do like tag 1, 2, 3, and then what? I mean, just this one? And
No, so right now, will the code make it so that all you have to do is it'll only show the results that have the tags in that exact order, or will it just show results that have all the tags?
It is ordered. It's also deduped. It's the insertion order. So actually, it's a good to look at the actual implementation. So this particular data structure linked hash set is said to be it uses a double linked list to kind of preserve the order. So when you are inserting those things, it is preserve the order, and it like a so it's not random. If you just use a normal like hash set, when you getting the results back, it doesn't necessarily preserve the order when you insert it. So you can have some kind of iteration. The iteration order is preserved. So if we look at the examples, like we have those like orders is more or less preserved, but if we do things twice, right, in this case we have a duplicate and one thing, it will give you an order. It will have some sort of order, be like the second one didn't make in because of duplicate, but it will give you some kind of order, and the order will be similar to the order you put it in. Right. This is more like a user experience type of things, but it's just a data structure you choose. Right? If you choose a hash set, and it doesn't necessarily preserve order. Like when we actually make them into a because those tags are stored as comma separate strings in the database. When it's stored in the database, it doesn't actually know what you want to get when you read that data structure out. So this is this is just like a conversion, and also so the developer kind of rewrites this to make it more elegant. If you look at the syntax here, it's using somewhat of like a functional programming style, versus this is a kind of this is called this is like a more like a procedure way of doing things. So here you see those are construct by saying I split, I make it into an iterable, and then I do filter, and then I do a collect. So these functions all called on the same object. It's chained together. The functions, the result is you can chain the results. So this input is the strings. We do a split, and the result is immediately convert to some iterables, which means we can. It's like a linked list, or they have an order you can iterate on, and then we do filter. So those are like chained functions. But if you look at the previous implementation, those are more like a procedure. Like each statement is they're separate. We use regex. We use like step by step. Do some replace and construct the string. So this way, if you're familiar with this way, it's kind of more high level. Right? You look at and more English natural language to kind of express intention. This is not that straightforward, but it's like step by step. We do some replacements. They have similar results, and this particular data structure is we kind of preserve the order. I think that's that. I'm not sure that answers your question, but hopefully give you some idea about, like, you choose different data structure, you can have different properties. The caveat is the caveat is if you only use hash set, the order you store to the database not necessarily preserve order. So that's why we use a link hash set, so because it has a linked list underlying it. Then when we iterate through it, they kind of preserve the order of the tags. So all the other thing is more or less the same when we change the signature of the query. There are some other changes about to help the browser to help the IDE do a better job of understanding the code. I haven't tried this. So the developer said if we have if we don't use this mute keyword here, and it's still the program still could compile, and we get better IDE support by having those types be like more recognized by the IDE, because the IDE is working by looking at the code and try to do some inference, like what's the type, what's the relationships. So in the IDE you can jump and forth back between the definitions of a function. So here are some changes about like the older code, and change some signature for the synchronization code. So one thing he added is this one, this type. So this will help the IDE to understand this particular data structure as a type, because there are some macros when we're using these libraries, like this particular piece. This particular piece is using this library and have this kind of structures. Under the hood, this structure is controlling the synchronization piece, like the interface for synchronization piece. So this is not a standard Rust trait definition. You see this annotation here, this particular line. So this triggers the compiler to actually look into what is this annotation means, and they do some macro expansion to make this piece, to automatically expand this piece into a concrete implementation. So here this type, particularly this type, like declaration, making those like macro expansion to be more friendly to the user, to the programmer's IDE. Right, there are some other changes, like because this is pretty much a big commit, so there are some other changes. Is kind of adjusting the syntax. All those are more like single query changes, the same thing, the function signature changes, and some other changes. The changes, the majority of the changes, like all those like small changes, because of those libraries is getting like upgraded. For some of them maybe downgraded, maybe for some reason. Like some of them is upgraded. You see this particular library, Tokyo, I think, like it's from 0.3 to 1, and like this version is from 0.6 to 0.8, and some other things. So those changes actually will result your, like the change management will result your code to be like either incompatible or you have introduced regressions, right? If you look at, so each of those library, the dependencies changes, they will also in some way change their interface, like those functions, the function calls without parameters, they change the parameters, change their function call names, change those are the interface. The contract between dependencies change. So you see a lot of like those changes. especially like for circle light bulb. Right? This is a pretty big change. Right? The signature change, the name change, the query row name, the query row. So the beginning, this is like a giant PR, which is not a particular good practice. Like in a more like larger or many people working on the project, usually you want your PR to be smaller chunks, and each one of them corresponding to a particular like sized chunk, right? So and it's more self-contained within the PR itself. This is a large PR because this developer is pretty productive, kind of making a huge change. We also see those icons, SVGs. So here, eventually we get into the majority of the new added photo. Like this is actually the ISD. So this is actually the new graphics all about. So here I think we can switch to, this is a net new folder. We can switch to the idea and actually do a compile. So one thing before we do that, like we are like how do we switch to the branch? So we are, before we add master, you don't see, like if we switch the branch, right, in a different browser, like you see this folder only has a hello world application, like hello world, because this is where we are on the master branch. If we check out the latest branch, what you do, like you probably need to fetch to get the latest like branches, and if you check out like the branch name, so now if you switch this branch now has all the code. It's not merged to master yet. So if we look at the actual dependencies, the master branch is here, and this branch is already having a lot of progress. And so if we switch to this branch, you see the new files, new changes, all together. And we are going to run it. And so we already have this is the main function, which is actually the entry point of the ISD program. If we double click here, it's going to compile this target. Take a little while. Yeah. After it's complete, it's actually I think it's running it. So the first time it's running it, it's also print out some logs. Right? The actual ePrint to help us. So if we do something, you also see you see actually what we did for the previous action is also reflected here. If we want to delete them, we can actually delete them. So the delete function is also implemented. So one thing you look at this, like the performance is not necessarily faster than the Electron implementation. The Electron implementation probably gets similar, even just from the action. similar results, similar, maybe even better. So you can kind of appreciate the browser is actually doing a very good job of rendering those graphics, and even this browser engine. This is a whole browser, right? This is a browser rendering versus it's more like even Rust graphics implementation is not really mature, and you compare the achievements of the browser rendering versus the native implementation of graphics. The browser actually is not losing on the performance side, at least for now, without doing crazy optimization stuff. So this actually works after we switch the branch. So we'll take a look at the main structure of this code. And so this piece of code actually has a lot of files. We have a main file here. This will be very similar to what we already reviewed for the previous some of the previous examples, but we'll take a look. So here is the main function. This is the entry point. We have a run function. We have a custom defined enum type, which is defined also in this main file as a loaded. So this is like a placeholder for everything, and it runs a setting with some default font and things like that, right? And here we also have some loggers, so maybe we're going to use some loggers in our font. We have a message. We have a lot of message kind of corresponding to the events we're going to happen on the UI. And here is the application, and this is the implementation for the application. So this is where the bulk of the implementation is. So it's implemented kind of the update function, which is the from SD framework perspective, this is the function we must implement it. We also have view functions. This view is kind of lay out some stuff. We have containers, we have some other things. So let's take a look at this update function. This is a good big function. Messages, so update is dealing with messages. So if it's loading, it's trying to do something, create database and do some configurable views. There are search bars. There's a middle data. You can guess it's probably the data come back from database. We have some encode. We have data view. So seamless data view is going to be the bulk of the UI. And we then also have, if it's loaded, it has some other things. Right? And we have different messages, so different kind of messages. We have search bar message and different messages. So let's look at this view. This view is a container with a text loading. And we also have another view. So it seems like I have two views, loading and loaded view. So if it's loading, it seems to display some text. If it's loaded, it's going to actually display the data. So we have this data. So the bulk of the UI should be the data view. And this middle data is it seems like it's the bulk of the data we get back from the backend. Let's see where this data view is defined. So we have data view defined as an attribute of this data structure of this particular data. And this is This is a struct holding that particular structure. So this seems the data, like actually the main data structure to control the UI. And here we have a data view inside, a resource, config, progress bar, page bar, which makes sense. So we have this implement on this data structure. The data also itself has some update functions, kind of also doing messaging, and it also has a view and do some alignment. And here we have a resource, we have a connection. You can guess this is the SQL connection. So from this main file, we kind of identified the critical data structure. And this piece, this one is very important. It kind of holding the main data structure of this application. It has a data view reference. So yeah, we have a data view as a sub component of the data. So here we can guess it has tags, it has nodes. So we can reasonably guess it's going to be corresponding to, like, the tags are going to be corresponding to this. The nodes are going to be corresponding to the items, to the actual each record. It has some states. State is like a UI state. It has a score, node score. So two kind of scores. We take a look at this data view. It has a middle data structure, so we call it middle data. It's a structure of doing encoding, so we can also guess, like, this is the corresponding data structure of actually doing the serialization. When we see serialization, we actually means the translation from a different format to a format which the language understands. Why it's called is like serialization? Because it's like if you think about telephone lines, right? Like in the old world, a telephone line is a line, is a physical wire, and everything you do, if it's not a digital signal, if it's like an analog signal, you push a signal over the wire, it's going to go sequentially. That means, like, if you just naively push like a voltage, or just change the electron, or change the voltage, or change the like electrical properties of the wire, it's going to be fast and speed of light, but it's also going to be sequential, right? You change something from the source, the destination is also going to get it by, let's say, like, order. So the digital, now our data, you see the digital and the analog. The digital signal is doing more advanced things, like breaking the channel into, breaking the one wire to multiplex, to kind of sending multiple different mixed channels and mixed frequencies together. So, and then you encode and decode. You can have one wire to send maybe like 10 different isolated, separated channels. Right? So one wire you may support by some clever time sharing. You can send like 10 telephones at the same time. So serialization, this word is coming from, like, if you think about that, there's a most naive situation. You're going to send your signals in order and serialized at the other end. So the other end is going to piece together what the original source is. So here is this middle data is kind of the same thing, right? If you remember our data structure from actually, if we doing anything, right? If we're doing anything, we get like the SQL statement is doing something like this. This SQL statement is going to generate a response. Right? That response is a string, is a JSON data structure. And we need to translate that string, a JSON data structure, to a Rust structure. So this is the kind of deserialized. So the implement deserializes function. So it deserializes this string back to a valid, legal Rust data structure, which corresponding to this one. So the JSON data structure have those attributes. So if you look at if you look at this message, right, this if we do so we actually see this is a shrinked version of the response. We do have, in the response we have a count field. So this count field actually corresponding to this field. Here we didn't see, but like how we display those nodes. So we also actually the response we get also have a nodes like a field, and then we have days and tags. That's how like every action we did here. It's actually return those response. And if we change something, you see the counts also change. Because we issue a new query, we get a new response, we get a new nodes data structure, we get new tags. So the nodes and tags are displayed here and here. So this middle data is handling that serialization, deserialization. So that's you see those encode functions. Those encode functions kind of turning the nodes and tags from the raw string data to a Rust data structure and tie them back to the UI, the UI data structure. So kind of massage the data from the raw data into a UI data structure. Because on the UI you start to add in user interactions. You have those update functions. You have user triggered functions. It's not the same as raw data. So from the string to a more structured data depends on language. So every framework, every language, you're doing similar things. Always trying to add in behaviors, add in interactions from the raw data you get. People have multiple ways of doing that. Like you heard, like model view controller, MVC, MVP, MVVC, different ways of linking the actual interactive things, like this controller or UI piece to the actual data, like the model backed by the raw data, but the model itself have behaviors, right? How to update. So they are so this data view kind of doing this deserialization and encoding, and kind of translating the raw data into this data structures, which make a lot of sense. And here maybe a auxiliary function to deal with days. So I think this main function make a lot of sense. And let's look at the search. Those are more UI type of things. So we see it follows the update view pattern, like update view implementation for those structs. And those structs is more like search bar is kind of having, will have state or have something about the UI, and the view is dealing with the logic, right? We see those unpress, we see those alignment. So we can see that it's kind of describes the behavior of how search bar should behave. We see the tag. We see the tag view. We see the row, and we also see those has unpress functions. They kind of trigger the message. Right? We click on the tag, it's trigger something, trigger a message. So I think this is straightforward. Here is a wrap. Component, which looks pretty, which actually is more low level. So here make a comment is that it's like a component could be generalized and actually go back to SD maybe. So here he's trying to do, I think he's trying to do the behavior of this particular wrapping behavior. So you see this this tag is continue on a different line, on the second line. Right? So if we enlarge this window, the tag is you get this particular behavior of wrapping around. And in order to achieve that, for SD, actually you need to implement some low-level things, right? The layout, some mouse overlay, and all those lengths, rectangle size, do some calculation. So this is different than the business logic. If you think about this way, this doesn't really deal with the particular data. This is like how we draw the UI, how we doing a particular component. So you see this implementation is very technical. Is more about calculate the layout of the UI, doing paddings, doing left and right calculation, and also we see a lot more language construct for like the proper message, the proper data structure getting matched, and those kind of lower level event controls with draw functions. Right? So that's why the author said it could be generalized, and probably pushed up level to the actual SD, which makes sense because those are not really related to this application, right? From the isolation of responsibility, this is more like a graphics library, like the GUI UI library. It's more proper to be pushed out from the business logic. So actually we have this component. Also we have a node. We see some behavior of this node. So in general, if you see what is a node is a record here. If we have some behaviors, we have clickable URLs on this item. We also have like QR code. We have those behaviors when we click on a tag, it's doing a new query. So it has some behaviors attached with this, but it's also replicated. Right? We have every single one of the record has same behavior. So it's perfect to abstract it out to be a node. So this node actually has a separate folder. It's a module of itself. It has a tag. It has a node view. It also has some like behavior to support the behavior of this section. For some, it could be reused. We can take a look. It also implements this edit, which is not actually in the electron piece. Actually, you can edit the node. And we have those tags. We have those messages. We have the tags. We have the states. So they pretty much follow the same pattern. Right? Or we have updates. Update are kind of getting the message. For each message, we deal with the kind of changing the state of the UI, adding tag view. So this piece, I would imagine like the tag view is basically this particular piece of implementation on this. So if you think about the node is the larger container, the tag view is this piece, and we have some other component here. So I'm curious if we can find the wrap. We should be able to see the wrap is used somewhere. Let's take a look. So we call the wrap WARAP. So let's do a search. I'm just curious where this wrap is used. Wrap, use wrap. So use here, use to here, and also okay, it's actually used here a lot. It's inside its own implementation, but where it's used, I would imagine it's used in the tag, right? If it's going to wrap the tags. Let me find it. Interesting. Okay, so probably it doesn't have direct reference here, but it's got to be used somewhere. Okay, new wrap. Right, so we see the actual usages here. It has a container, it has the tags, it fold, like we try to, what is this tag? The tag is a data structure. It's from the data view, is those tags, right? Yeah. So here we see the concrete usage of wrap, which is from those tags we iterate, and for each tag it's kind of using this wrap data structure, and eventually it goes to some container. So it's a correlation, right? The linkage between the tag and the wrapping is kind of linked here. Very good. We'll take a look at what this tag is. The tag has some unpressed functions, right? Unpressed, when you click on it, it has a message. There's a delete message, there's a like enter message or different messages. So I think that's pretty much like a high level, right? The structure of the current state of this application. So the developer is still going to be making more progress, but so far I think we have some understanding of how the code is structured, how the data is flowing. Any questions?
Wait, can you just explain a little bit what the P means?
Can you say it again? Key.
It says like pub struct. Like I know what struct is, but I don't understand the pub.
You mean the inner? Oh, inner. You mean the inner? So in Rust, right? Let's look at the official definition. The inner type. I think it's like struct, but you have more constraints for the inner, because inner is going to be is going to have more constraints. So so in the other language, like in Java or C, or Java has inner, right? Those are like you can think about those are like a value, a fixed value in a fixed set or in a category. It's like a enumeration of the names inside a category, and it's a full iteration. So here you see that IP address has two types. Have two types of things, right? v4 and v6 type of things. So once you use this, you kind of properly describe a I would not say hierarchy, but you kind of describe the space of the naming space. Really, you can really think about it's a naming space type of things. So really, this way is like you give some structure of a naming space. You hold you create a structure, right? You create or a hierarchy of this particular naming space, and those naming space has their values. Um, so those could be used. Those are legit variables and legit values you can use, right? So you see, once we defined this, you can actually assign them as values. So they are, so just like if you define a home variable, the struct is like a container. You can think about struct as like a container, or like a blueprint of container. It's not a concrete thing, it's just a blueprint. Only when you so the struct itself, right, when you're writing this, it's not really exist yet. It's just on paper, or just like a design phase. You have a blueprint for what is the container is going to look like. What's the type of the things the container can fit? You can have address fit into as a string. So this container, you can think about it have two elements. Each element have their types described. But the struct itself is not initialized. What does it mean? It's like it's not really a thing yet. It's just a blueprint. Once you do this, like a let statement, you initialize it. You actually have a concrete instance. Like the home variable here is a concrete instance now. Yes, I'm creating a home now. I'm creating a container now, and I'm using the blueprint of this container, and I know this type must be having those their value must be like the inside of a container. Like these two things must exist, and they must have those types. And here, this one type, right, is specified as an inline type, and it also specified a value, the inline type and the value. So for inline itself, you can think about those are values, right? They are not like struct. Struct is not, it's like a blueprint, but inline is a concrete. Those are concrete values. V4 and V6 are concrete values inside a namespace. I hope that gives some idea, but there are some caveat things, I think. You can also define like behaviors, right? Inline can get in. They can have own structures. They can have their own structures. So in some extent it looks like a struct, but I think you can also implement like more. You can have more like hierarchy inside those things, like inside each subcomponent inside the inline, right? So I think you can also have behaviors, right? To some extent, it's like a struct. You can do behavior. You can implement something on this inline. Like those, you can add in functions to inline type, and the inline type has those like concrete values, but also it can have like not concrete values, right? So if you think about this one, the quit. They don't have like any other things, so the quit itself, you can think about it's a concrete value, and those things, it's not really fully initialized yet, right? The XY is not really initialized yet. They have the type description, but you can start to implement the behaviors by implement things on inlines. So it has so here I say it has advantages, right? You can always it seems it's like if you use a inline, you can think about like how to properly naming your kind of conceptualize your problem and give each one of them have a good name. So usually it's a definition game. So if you can define your problem, like technically, if you can define an accurate term for your problem, you kind of successfully like design your problem to a large extent, like even without behaviors. So you can think about Innan can help you doing that by kind of conceptually or in your mind break down your problem into smaller pieces and kind of maintain some hierarchy. I would say it's like a struct, but you can have concrete behaviors, or you can have like concrete values in those struct, like in those things. So it's like a mixed it's a mixed instance, and also like abstract some abstractions. I hope that give you some insight. I may be totally wrong, but that's probably my take on it. You see those are used to those are used a lot to do those naming, to do those namespace type of things, right? That's a message. We give it two types. It's come handy because if you don't have this data structure, you're going to have some kind of other mapping, right? Like in the old days or in some languages, you're going to say, okay, message, I'm going to give a message a number, like 001 message is going to be this particular meaning, English meaning, right? This particular meaning. So if you don't have Innan, you're going to have some kind of indirect mapping to describe a particular concept by doing another mapping, maybe using some other types. Like in the old days, even for like Java implementation wise, those Innan are like integers. In the concrete implementation, like for Rust, it's the same thing. It's actually, when you see the data structure, it translates to very efficient, like in the memory layout point of view, it's very efficient layout. Right? Those are some memory blocks. They kind of have I don't know exactly how they implement, but like those two are kind of two, maybe integer or maybe some kind of value in the memory to represent the two different things. And every time you reference to it, we know the mapping actually means those things. And it allows you to use this in the other cases. I think this one thing is also very like null values is also very like a big problem. Probably you heard of like Java has the null value problem as a billionaire, like a billion dollar design fault for like a null value. So that's really, when you have nulls, right? It's really one thing. It's really like you haven't described your namespace 100%. You have a null, empty, or whatever undefined behavior. That basically means your design is not complete yet. Right? You are focused on the happy path of your program. You have focused on the workflow of 95% of all the cases, which is good. Sometimes it's good enough. But really, if you think all the cases of your problem, all the systems, right? You shouldn't have undefined behaviors. You should not have undefined behaviors, right? Like from a philosophy point of view, everything should be designed, should be properly named. All the errors, exceptions should be properly categorized, have a name. Right? So Innan help you do that because if you can list all your state, all your problem, properly name them, you're not going to have like an unknown type. Right? Even it's unknown, it's better. It's if you think, okay, I have an unknown message, it's better than like when you are running something, like the language natively support a null value and undefined value, right? Even you do this, it's still a good thing, right? Like it's still clearly listed out in your program. Okay, I know I have some unknown messages, I have some unknown things, and the language kind of surfaces that. It's very bad for you to I defined only two things here, but in the end, in my code, I need to deal with somehow they're unknown and now empty pointers, those type of things. So Inan help you trying to design your, trying to enumerate your problems most roughly. It's not going to be 100%, like all those other things. Rust even you also have panic and all the other things, but it's doing a much better job than I think the previous languages struggle with, like null values, empty values, undefined values. Eventually you had. Cool. I think that's the time.
Yeah. Okay.
Next
understand
next week we'll probably see some more progress.
Okay. Bye.
Cool. See you.